Good morning class 9. Welcome back to our online classes. So we were in chapter number 2 discussing polynomials. We have discussed what is a polynomial, what is the degree of a polynomial, and based on the degree how many different types of polynomials we can have, right? Today we will discuss zero of a polynomial. So as the definition says, in any polynomial, say we represent polynomial by p of x, q of x, whatever it is, variable is x or it can be variable can be y or any other thing, right? So the value of variable at which the magnitude of a polynomial becomes 0, that value of the variable is called the zero of the polynomial. To understand it better, let us consider an example. Say I have a polynomial p of x equal to x square minus x minus 6. Now this is a quadratic polynomial. What happens if I take, say, at x equal to 3, let us find the value of this polynomial, magnitude of value, whatever you call it. So p of 3, in place of x I have taken 3. 3 square is 9 minus 3 minus 6. 9 minus 3, 6. 6 minus 6, 0. So we can say x equal to 3 is the 0 of polynomial p of x equal to x square minus x minus 6. So x equal to 3 is called the 0 of the polynomial. Why? Because at x equal to 3, the magnitude of polynomial becomes 0. The entire value of the polynomial becomes 0. Say let's take one more example. At x equal to 2, let us see what happens at x equal to 2. P of 2 is 2 square 4 minus 2 minus 6. 4 minus 2 is 2. 2 minus 6 is minus 4. Now this is not 0. So at x equal to 2, the value of polynomial is not becoming 0. So we can say x equal to 2 is not the 0 of this particular polynomial. What happens if I take x equal to minus 2? So p of minus 2. Minus 2 square is 4 minus 2. So minus minus plus, 4 plus 2 is 6, 6 minus 6, 0. So we can say x equal to minus 2 is also the 0 of this polynomial. So the question arises, how many zeros are possible to this polynomial? So children, no matter what is the polynomial, always look at the degree of the polynomial. If the degree of a polynomial is 3, you will have at most 3 zeros for that particular polynomial. All 3 can be different, or 1 is different, 2 are same, or all 3 are same, right? It can happen. It may also happen that the zeros may not be real. The zeros may not be real. That you will study in your higher classes. What are they? But for your knowledge, whatever is the order, whatever is the degree of the polynomial, for that particular polynomial, you will have that many number of zeros. Those zeros can be real, those zeros can be imaginary or complex, whatever we call it. But always the number of zeros of any polynomial is always equal to the degree of the polynomial. So this was 0 of the polynomial. Hope you understood what we mean by 0 of a polynomial. Okay. Next is remainder theorem. What is remainder theorem? So a polynomial p of x is given. Okay. If p of x is divided by a linear polynomial x minus a. X minus a is a linear polynomial. A polynomial p of x which has a degree more than 1. It can be quadratic, cubic, biquadratic, whatever it is. If it is divided by a linear polynomial x minus a, then the remainder is always p of a. Remainder is always p of a. In the polynomial p of x, substitute x equal to a. You are dividing it by x minus a. Remainder will be p of a. The question is, what if I divide it by x plus a? In that case, if you are dividing it by x plus a, the remainder will be p of minus a. Why? Why do we say? We have studied that suppose x minus a polynomial is divided by x minus a, then remainder is p of a. Suppose the remainder turns out to be 0. It means x minus a is completely dividing the polynomial, leaving the remainder 0. So this is a factor. This is a factor, right? So if I take, if x minus a is considered to be the 0, so x minus a is equal to 0. This implies x equal to a. So in place of minus a you have plus a. This becomes minus a. Understood? So this is remainder theorem. Whenever a polynomial of degree more than 1 is divided by linear polynomial x minus a, then the remainder will be p of a. If it is divided by x plus a, the remainder will be p of minus a. Let us understand it by the help of an example. P of x is equal to this is a polynomial. So I will say p of x is divided by x minus 4. What will be the remainder? It is being divided by x minus 4. So remainder will be p of 4. Substitute 4 here. 64 minus 24 plus 44 minus 6. 64 plus 44 is how much? 108 minus 30. It turns out to be 78. Remainder is 78. Got it? So this is what remainder theorem is. Okay, children? So we have discussed 0 of a polynomial. We have discussed remainder. Now this remainder theorem concludes the factor theorem. If I am dividing polynomial p of x by linear polynomial x minus a, the remainder is always p of a. If p of a becomes 0, means the remainder becomes 0, then what do we say? We say that x minus a is the factor of the polynomial. तो इसको थोड़ा सा बढ़ा देते हैं, डेफिनेशन को थोड़ा सा एक्सटेंड कर देते हैं. Now if p of a is equal to 0, then we say that x minus a is a factor of polynomial p of x. So remainder theorem concludes the factor theorem. Remainder theorem से थोड़ा सा आगे चलेंगे तो factor theorem आ जाएगा अपने पास. So we have discussed today 0 of a polynomial, remainder theorem as well as the factor theorem. On these topics we will have questions in the next class.